So let's look at this and see why I liked it. I liked it because there's a little flow chart of what to do. And hope, again, this should all be a review, but this is the way you should kind of think through things. Always factor out the GCF if one exists. Look for that first because that can simplify your life. The truth is, and I think it says down here somewhere, is that sometimes you can factor this stuff without factoring out the GCF, but then in the end it's not really factored all the way, and the numbers are smaller, makes it way easier if you can just factor out whatever you can before you start, okay? So we look at, is the equation a binomial or a trinomial? Right, so if it's got more than 3 terms, so that makes it a no, then we've got 4 or more terms, which means we're going to factor by grouping. That's why grouping is important, because that's what we're going to do on something like that. Okay, but if it is a binomial or trinomial, we're looking for special cases, and that's what we're going to look at for today. If it's a binomial, we look to, it doesn't guarantee that it's one of these. Does yours actually say A there? Oh, it doesn't. It's like a point. I don't know why that is. All right, so let's fix that. I don't know if that's something I did or if it was like that. But clearly it's not going to be period squared minus b squared, right? This would be an A, so fix that. So difference of squares, sum of squares, difference of cubes, sum of cubes, right? And there's all these little footnotes that are really not footnotes because they're up a little bit, but they're like superscripts. But the sum of the squares, that's not anything we can factor. That's why it's called prime, right? And so it's prime because it's not divisible by anything except 1 in itself, but that's not still 100% true. It's not just that it's anything. It says up here, prime polynomials cannot be factored using integers alone. Because if you think about it, sometimes, or if we have something like that, could we put it in the quadratic formula? Could we put a trinomial we can't factor in the quadratic formula? And maybe we get imaginary answers, but maybe we get real numbers. They're just like yucky square roots. So they are, we can get numbers. It is divisible by something, but not just integers. And so that's what it's getting at there. All right, so, but if we have this, there really isn't any little trick here. Difference of squares, hopefully that's just fine. Difference of cubes and sum of cubes. And what I liked about this is, I don't know if anybody's ever taught you SOAP, okay? But you usually all know what to do with the A's and the B's. It's the signs that get all messed up. But if you can remember SOAP, that means that whatever this sign is, it's the same, opposite, always positive. See? Same, opposite, always positive. So hopefully if signs were ever an issue for you there, it's a SOAP. Same, opposite, always positive. That's for the cubes. If it's a trinomial, we could have a perfect square trinomial, either with this being positive or negative, right? And then sum of squares can be factored using imaginary numbers, so that's here. But it's okay, we're not going to really look at that right now. But these things, there's no special cases, then we can factor by grouping, completing the square, or using the quadratic formula, or Dirty Harry or whatever else, but just other things. Okay, so maybe you don't need this because you're just a rock star at factoring. That's highly unlikely for everybody because that's usually what is the issue for a lot of people. Doesn't mean that you can't, and doesn't mean that you're not a rock star, because I'm sure a few of you are, but hopefully this is a handy little thing to have as we go through this. Okay. All right, so now let's look at your yellow paper. Since this went on, what page did you glue this on? 59, okay. So then this is going to go on page 60. So page 60. And each one of my little slides here is going to be one of these boxes, okay? So in this little box, page 60, I guess you would actually write it there. We're going to start right here, top left box. Okay. So the title for the notes themselves is Factoring Special Cases. Still in this top left box right here. Yeah, turn it like this. This will be better for you because otherwise when you write like this, some of your equations are going to be kind of long. It's going to be better for you to have it sideways. Everybody sideways? Okay. Wait a second here. All right. Set it for me. There we go. Okay. You plugged in? Okay. All right, so still in the top left box here, we're going to write, and we're going to write this, you take the whole box for this, G, C, F. All right, going very basic here. What does the G stand for? Greatest, right? Okay, that is the part that if you're going to mess something up, that's what you mess up. you don't really have a problem with the common factor part of it. It's the greatest part that gets you in trouble sometimes. So make sure you're always thinking the greatest, not just the common, okay? So greatest common factor. And those are the first examples we're going to do, which should be hopefully super easy. Okay, so that was your top left box. Now you're going to go to the top right box. Okay? We're going to do 2 examples of GCF in this box. Okay, the first one is going to be 8a to the 4th minus 14a squared b. Do it in pieces so you don't miss stuff. Okay, I know you factored a ton in Algebra 2, but these are the kinds of things that you still, and I don't think it's that you don't get it. I think that it is simple and it's the most basic part of factoring, so sometimes you just zoom through it. That's when y'all make your mistakes, is when you're flying through things. Okay, so what's the largest number I can factor out? 2, okay? Can I factor any a's out? Yes, so that would be 2a squared. Can I factor any b's out? No. So that leaves me with what? 4a squared minus 7b. Then I should look to see if I can factor that. Can I factor that? No. Okay, so we're good. Awesome. See, I knew y'all were going to be awesome at this. All right, so 11a cubed b cubed, I'm sorry, 11a cubed b minus 22a squared b squared plus 55. Okay, still in that same box. All right, so what's the largest number I can factor out? 11. Can I factor any a's out? Nope. Can I factor any b's out? Nope. So that leaves me with a cubed b minus a squared b squared. Oh, 2, sorry, thank you. Dang it. Minus 2a squared b squared plus what? 5. All right. Don't mess up on GCF. You'll be able to do that just fine, right? Okay. Bottom left box. Give you a squared minus 16a plus 64. All right. Is this a special case? If you don't recognize whether or not it's a special case, can you still factor this? Yeah, you can totally factor this. I mean, you can do this. It's not a crazy hard one. If the numbers get yuckier, though, and it's a special case and you can't recognize it, then you're just making your life harder, right? I mean, these are pretty simple numbers. You should be able to factor this just fine. But this is a special case. What is this called? Okay, if it's going to be the sum or difference of squares or cubes, then it's only 2 terms. This is 3 terms. So you should look at your little chart. What do you think this might be? What's the only thing that we had for a trinomial? Perfect squares. So this actually is a perfect square trinomial. And when we do these two, I'm going to, and there's just going to be one in this, so you got tons of room. I'm going to write extra steps that you wouldn't necessarily have to write. I just want you to understand how you tell and how you know. Okay, so this a squared. Basically, can I take the square root of this? It's a, right? So the square root of that's a. So it's a squared. Then minus something plus, what's the square root of 64? 8. Okay. So if this is a perfect square trinomial, then this right here has to be minus 2 times a, which it is, times that right there. Is that what we get? If I fix this back, redo it, do I get this right here? So then it's a perfect square trinomial, right? So that means that my answer in the end just looks like this. This is what comes first. This is my sign right there. Then get 8. So if you can recognize that it's factored like that, you don't have to go through any of the other steps. I basically just factored this out. Because if you look at your rules that are here, this says if this actually is a perfect square trinomial, this is x squared minus 2x times y plus y squared, right? So my y is my 8 here. oh, wrong one. So this is x squared minus 2 times x times y plus 8 or plus y squared is the way it goes with that pattern. So that's why you want to take the square root of this, you square root of this. If this right here is 2 times this one, it's a perfect square. You don't have to do anything else. Okay, does that make sense? We good? Questions? All right, go to the one to the right of it. So bottom right box, I'm going to give you this one. I'm going to give you a minute to do it. 4y squared minus 12y plus 9. Okay, factor that one. Can I factor out a GCF here? No. Okay, so it's a trinomial. My only special cases for trinomials are perfect square trinomials. So I've got to see if it works that way. So if I take the square root of 4y squared, I get 2y, right, squared, minus, I'm going to leave the middle blank for a minute, plus 3 squared, right? So this right here has to be 2 times a, which is 2y, times b. You can use a and b instead of x and y. Use that. So this comes from here, and this comes from here, and the 2 is just always there. So if I simplified this, would I get what I have in green? Yes or no? Yes, right? This is 2y quantity squared is 4y squared. Negative 2 times 2y times 3 is negative 12y. 3 squared is 9. So that means in the end, this is a perfect square trinomial. This is my first term, 2y. This is my sign, minus. This is my last term, which is 3.
So the formula for the perfect square is basically, like for the middle part, it's 2 times 8.
Yes, every single time. So, yes, every time it is a squared, either plus or minus, in this case, minus 2 times a times b plus b squared.
So how do you know if it's minus?
It's whatever it has. It's whatever it has right there. Yeah. Everybody okay with that? We good? And that's what it just uses x and y on that little flow chart that I gave you. But yeah, that's your rule. Worst case scenario on these, you just factor them like you factored other things. It would just take you longer. And if you can start to recognize these things, you can get through it a whole lot quicker. Okay, we good? All right, open it up. Top left box. So if you have it long ways like this, it'll be up here somewhere. Alrighty. So if I give you 4, actually let me give it a better color. 4x squared y minus 36y. Yeah, yes, sir. Top left, when you open it all the way up, top left box. And we're going to go left, right, all the way down. Okay? Sorry, I do that to try and make it better, not more confusing, and sometimes it ends up being more confusing. All right, so what do you think? Use your little flow chart. Some of y'all don't even have your flow charts open. Use your little flow chart. And is this a special case? I heard a quiet yes over here. Does it? Does it have a GCF? What is it? Y. Okay, so should we factor that out before we even worry about that? Whether it's not that's a special case? Absolutely. Always factor out everything you can. So what can I factor out? 4y, right? So 4y. Then I'm left with what? X squared and what? Minus 9. Okay. So now is it a special case? Yes, two terms, what is this? Difference of squares. Right. Which means this guy, this is why before, when I go back over GCF and geometry, much like I probably did with y'all, some of y'all might have made this same mistake, is that people want to factor out the GCF and then it like disappears. Like we think we just, oh, it doesn't even have to be there. I factored it out. Oh, that's just what I'm left with. But we know we cannot let that go, right? Drives me nuts. This is a still important part of it. So 4y is still here, right? Since it is the difference of two squares, I'm going to get two binomials here, x and x, because it's the square root of whatever this is. What do my signs look like? Plus and minus, and then the square root of this, which is 3. If we had only factored out the y and not the 4y, would it still have been a difference of two squares? Yes, it would have, because those are both perfect squares still, but it wouldn't have been factored all the way. You still have to factor it out. Okay, are we all good? You do that one? All right, so go to the top right, so the one to the right of it. So we're going to go left, right, all the way down. I'm going to give you 16 n to the 4th minus 1. Factor that one. I'm going to go check. Everybody's here. Yes, yes, yes. Is this perfect square? Difference of squares is what I meant. Yes, it is. Okay, so we get this, right? So plus and minus, what goes here? 4n squared and 1, and 4n squared and 1. Is that factored all the way? No, it is not. Can I factor this one anymore? No, but I can factor this one some more, because is this a difference of two squares? It is. So just because we use a rule doesn't mean we're done. This I can't do anything else with, so it's going to continue just to be 4n squared plus 1. But then this one is also the difference of two squares. So I get plus minus again. Square root of 4n squared is 2n. 1, 2n, 1. Okay, everybody good with that? Questions? Okay. All right, so go back over to the left. We're going left, right, left, right. I'm going to give you t cubed plus 125. Using your little flow chart, is this a special case? We've got two terms. So we go down that side. There's no GCF. What is it? Sum of cubes. Okay? So this is the sum of cubes. And we know that because this is the same thing as t cubed plus, what's the cube root of 125? How are y'all not 5? 5, right? Y'all did do cube roots before, right? 5. It's 5. The answer's 5. Okay, 5 cubed, right? So remember SOAP. It's going to look like this. You're going to have a binomial and a trinomial. For your signs, they are the same, opposite, always positive, right? So what goes here and here is the cube root of each one of these. So this is t and 5, right? What goes here? T squared. What goes here? 5t. Make sure you can tell the difference between your t's and your plus signs, right? And then what goes here? 25, or 5 squared. Okay? SOAP, same, opposite, always positive. Should be a piece of cake for you. We good? Is it possible that this could factor? That never factors. Doesn't factor. Okay. Next one. So to the right of that one. me give you 64 minus a cubed. Factor that one. If you do that, then you need to make sure that you keep your signs correct. It's probably going to be better for you not to. Okay, because that you might confuse yourself with what's supposed to happen with the signs. Where here, it fits that mold exactly. I would just go with this. Okay. And then in the end, if you want to switch it around, do it then. I wouldn't do it at the beginning. What's the cube root of 64? When y'all did cube roots, you learned how to do them by hand, right? Did you learn how to do like the factoring tree just like you would with quadratics? Yes or no? Some yes, some no. Okay, so did you learn the fact, like if I wanted to take the square root of, or if I wanted to simplify a square root, you learn, well I know most of y'all learned it from me, the factor tree, right? And how you can take out pairs. In case you didn't know, because I'm thinking at least some of you may not have learned that, if I want to find the cube root of something, or even simplify it if it's the cube root of something, you can do it the same way. So you don't always have to go all the way. It just depends on what you're most familiar with the numbers. But for 64, if I just start breaking it down and I'm just factoring it, just like a factor tree you learned in elementary school, so then I've got 2 and 4. When you get to prime numbers, you circle them. And if you have to do something like this, you should get to a point where you don't always have to go all the way because you can start recognizing things, right? But this is what I have. So with square roots, if I was simplifying a square root, I'd look for pairs, right? Like we're playing Go Fish. But this is a cube root. So I'm going to look for sets of 3. So 1, 2, 3 comes out as a regular 2. And then this set of 3 comes out as another regular 2. That's why the cube root is 4. So you can treat it the same way. Again, I don't know if you were taught that. How were you taught to do cube roots by hand? Similar to that or different, or guess and check? Guess and check. Well, and sometimes you should start to recognize them, right? You can think, I mean, it can only be so many things if the number's small, like 64, right? And then if it's a perfect cube, you should know 3 cubed is 27, 4 cubed is 64, 5 cubed is 125 at the very least. So what's 6 cubed? 216, okay? And then you may not be even working with numbers. There's not even that many you need to remember that are the small common ones. But worst case, or if you've got to simplify that by hand, you do it the same way you would do a square root. Okay, so I said all that to say this. This is 4 cubed minus a cubed. Do you have to actually write this step? No, but it should be in your brain, right? Me, you should write it in your notes maybe. But SOAP, same, opposite, always positive. Same, opposite, always positive. And so this is backwards maybe from what you're familiar with or used to because the variable might come first. But we're going to go with this right here. This is 4 goes here, a goes here. 4 squared is 16 plus 4a plus a squared. Then flipping it around. I mean, if that had been a plus sign, then I would say, yeah, you go ahead and flip it around. But I don't want you to get messed up on the signs and how they work. Yep, it's just whatever the cube root of this and the cube root of this one. That's all it is. And then this is just like the little rule. I think they use A and B, right? So what they use here? Yes. So if you look at the difference of cubes on that little chart, it says like A cubed minus B cubed. And that's why I put it in this format right there so it would fit that. So that it's just A minus B, and these are both positive. And then it's just whatever this is squared, these two multiplied together, and then this one squared. Okay, everybody good? All right, awesome. Okay, so next box on the left. I'm going to give you A times B plus 2 minus 3 times B plus 2. What does this look like? Grouping. It looks like a step we get in grouping, right? But terminology is what I want to focus on here. There are two main terms, right? There's this term and there's this term. They have this in common. What are those things called? What's that called? It is a GCF, yes, it absolutely is a GCF, but this GCF is a little bit different, right? This GCF is what? What do you call when it has two terms? It's not a trinomial, but it's a binomial. Okay, so this right here is their common binomial factor. Okay, just want to make sure the words, that you've got the words and you know what to do with that. Right. So we have a common binomial factor here. Can we factor it out like a GCF? Yes or no? Yes, that's basically what we've been doing with grouping, right? So we just get b plus 2 times what? A minus 3. And we're done. There's really nothing else you can do with that. That's not really necessarily a special case. It's just something that it's a step that's in grouping, but that might not be the only time you ever see it is when you're doing grouping. We good? Go to the box to the right of it. Now I want you to do this one. M times n minus 2 minus n minus 2. Does this have a common binomial factor? Yes. Okay, so that n minus 2 can get factored out, right? What are we left with? M minus 1. Just checking on y'all, right? If you need to write that 1 in there, go ahead, but just know that it's not a 1. It is a 1, it's not a 0, and you don't just pretend like it's not there, right? We all good? Good, good, good. All right, so bottom left box. Give you this. 20a cubed minus 5a squared plus 8a minus 2. Okay, so if we use our little flow chart, is there a GCF? No. So then it says, is the equation a binomial or trinomial? No, it's not. So we move on over, right? Not a binomial or trinomial, so it's got 4 or more terms. So what should we do? We should do grouping, right? So I can group these two together, and I can group these two together. Yes? So what can I factor out of these two terms? 5a squared. So 5a squared. That leaves me with 4a minus 1. And then over here, what can I factor out? 2. And that leaves me with 4a minus 1. Yes. Now I have a common binomial factor, so I can take out my 4a minus 1. That leaves me with 5a squared plus 2. Then you still need to look and make sure that you can't factor either one of these, because you still may be able to factor something. Can I? No. Okay, neither one of these is factorable at this point, but you still check. Don't just assume that you're done, because you could have other special cases. We good? All right, one more. We'll give you an opportunity to do this one. 9a squared b minus 8a squared minus 9b plus 8. Okay. Give you a second to do that one. So I have the first one, I can factor out an a squared. What do I factor out of the next one? Negative 1, good, because we want to stay positive. So we get 9b minus 8. So then 9b minus 8 times a squared minus 1. Am I done? No, because I can't factor this one, but what's this? The difference of squares, good. So it's 9b minus 8. And then I get 2 more binomials here. And what do they look like? A plus 1, a minus 1. Okay, good. We good?
So, we can combine 3 terms into 35.
Yes. Yeah, I mean, right now there's only 4.
And that was
Yeah, but if you had to, you could do something like that, yes. All right, any questions? Good job. All right, Miss McWhorter would be proud of you.